So today I'd like to talk to you about some of the great features, some of the new great features that are in VIPM 2012. But because I see a lot of familiar faces, and I assume some of you have used VIPM, I'm going to give you a few tips and tricks that maybe you didn't know about. And also, there are quite a few people that probably have not used VIPM a lot. So we're going to do a little bit of general overview at the beginning as well, just to familiarize ourselves with the entire workflow. So what is VIPM? VIPM is many things to different people. First and foremost, it's a deployment solution for LabVIEW code modules. It allows you to package up your shared code, code that possibly cuts multiple projects and keeps it, and VIPM lets you keep it under control and manageable. VIPM also provides system configuration management of your development environment. We all use multiple reuse libraries, and we use different LabVIEW versions, and we also work on many different projects. So to be able to I'm sorry, someone's complaining about my audio. Is this any better? Okay. So to be able to switch between projects and to switch between different LabVIEW versions, you want to be able to have your development environment back to the same state that it was before. And I'll show you how to do that with VI package configuration files. VIPM also allows your team to collaborate using repositories. You can have a central repository where you can keep all your reuse libraries and all your packages. And it provides a one-stop, always-on solution to have your code available remotely. One thing we're very proud of is National Instruments has adopted VIPM and VI packages as the standard for deploying LabVIEW tools and add-ons. And it powers actually the LabVIEW Tools Network. VIPM has been around for many years, and the LabVIEW Tools Network is a high-traffic repository. It gets thousands of downloads per day. So the back end of the repository system is very robust and has been proven. And something new for 2012 is that VIPM now ships with LabVIEW. So VIPM is on the DVD. VIPM is downloaded when you download LabVIEW from National Instruments. So that should make it a lot easier for you to get it installed, and does not require an internet connection if you have it on the DVD already. Why use VIPM as opposed to other solutions? VIPM delivers add-ons, tools, and code modules to LabVIEW software teams in a form that is natural to them. So one thing that is at the heart of VIPM is this tight integration and coupling with LabVIEW. And here I'll show you in LabVIEW 2012 all the different locations that you can install tools. First and foremost, you can do that in the palettes. And a lot of people like using the palettes. For example, in our new VIPM API, which I'll go through later, you can access it from the palettes. And there are people that do that. You can access VIs using QuickDrop. And VIPM lets you install your add-ons so that they're in both of these locations. You can target the file menu in LabVIEW. You can target the tools menu. You can also target the help menu. And in LabVIEW 2012, NI introduced project templates, and VIPM allows you to build project templates as well. So in order to be able to integrate into all these different areas into LabVIEW, you need a tool that understands the protocols, understands the standards, and is able to plug into these different areas without having to figure out what the standards are. So let's go through the package deployment process itself. The first step in any kind of packaging process, any kind of deployment process, is to actually create the reuse source project. And that involves extracting code from existing projects that you find useful and pulling them out, and so that you can use them across projects. Or you can take third-party drivers. A lot of us download drivers from ni.com, but they're not in a digestible form. They're in a zip file. Giving instructions to developers and say, well, you have to unzip it here, copy files over to this location is tedious, and it's not reproducible. So you can take third-party drivers, repackage them into VIP files, which are the package format, and then have them managed by VIPM. You can version them. You can make changes and have multiple versions where you can rev your changes. Or you can create new reuse tools. A lot of companies have reuse library managers, and they have people that their job is to create reuse tools, find the need, and create tools for the company. So those are different ways that you can collect reuse code. Once you have the code, then you do editing on the source, and that's basically standard practice LabVIEW editing. You can make code changes and improvements by using your existing source code control system. You still have to do source code control using SVN, CVS, Perforce, whatever is your preferred method. And then you do commits and versioning using your source code control system of your reuse library. How do you distribute it to others? That's where the package building process comes in. So you take VIPM takes that code and packages it in a single file in a format that VIPM understands, so that it can do the proper installation in the development environment. You can configure your palettes in an easy WYSIWYG format. You can provide versioning. Each package has its own version. You can do password protection. You can define system requirements. For example, it'll only work on this LabVIEW version or this version or greater. You can add a licensing agreement if you distribute your tools to your end customers. You can define dependencies, which we'll talk about that later. And you can do custom actions. This is my favorite part because it really expands the capability of what a package can do. Custom actions are basically anything that we haven't thought of that you want to do with your package. And custom actions are actually VIs that you write in LabVIEW. And while the package is installed, it actually calls these VIs from within the package and does various actions using LabVIEW. So you can actually do command line operations. You can, you can, as you're installing the VIs, you can apply certain changes to the VIs. So you can do a lot of different things custom on your own. And finally, after the package is built, you need to distribute it and install it on the target. And as we mentioned, VIPM packages target the LabVIEW environment, VI-lib, user-lib. And during the install process, VIPM also handles the mask compile process. So you don't have to worry about the end user doing a mask compile. VIPM does that for you. And provides version management. You can upgrade, downgrade, uninstall. And because of the custom actions, you can do things like install system components in Windows using custom actions. But also, as we'll see, VIPM also has the ability to target certain system locations automatically. So I'm going to go through a quick demo of the VIPM package building environment. So I'm going to switch to that. So from within the VIPM main UI, you can click on this package building icon, and that brings up this package building window. I've already preloaded it with a sample project that I've been working on. It's basically taking the Agilent 34401 driver and repackaging or repurposing it as a package. So the main area here is where you define, where your source is and where your final package output goes. Here you can control the versioning, and you can add release notes. Release notes basically are things that change between packages, and this information gets displayed in the package info window. So even though your code could be built, let's say in LabVIEW 2009 as your source format, you don't have to recompile it into 2012. So if it is in 2009, you can just say, I want to build it in 2012. And VIPM will just load it up in 2012 and rebuild the package in that format. So you can keep the source in an old LabVIEW version, but build it in a newer one. Of course, you have to have that newer one installed. We also have information here about company name, author, and so on. You can also add a licensing agreement, and this is where you would do that. You just pick a text file, and it would load it up and ask the user to confirmation before they proceed to install. Now here's where you edit the palettes. Editing the palettes, by default, LabVIEW goes through your source and generates some default palettes. So you can load it up here. And a little trick that I can show you here is if you hold down the control key and click the palette, it'll open up a sub palette. And holding down the control key and clicking will open up multiple palettes. So what this editor here allows you to do in a drag and drop fashion is you can click on an icon and you can drag it around. So it's definitely very intuitive. You can click on from one palette, drag it to another, and you can edit your palettes in an easy way. You can also insert VIs that are not auto-generated in the palette. You can define a place VI contents action. So you can do all your palette editing here. Another cool thing that VIPM allows you to do in an easy way is to create custom categories. And what this is basically is your own company category that could be at the root level of your palettes. And we'll show you that when we install a package to see how that looks like. Now this is where all the predefined locations are. Toolkit VIs is the default. Now, all of these locations are the recommended standard that NI defines for packages that go onto the LabVIEW tools network. But it's perfectly fine to use these same standards for yourself since they've been vetted out. But you can add your own locations here as well. So by default, everything goes into VI-lib under your company name and product name. And that can be changed. We can target the examples folder in LabVIEW, custom probes, error folder, help files that go into the help menu. We can target the file menu, the tools menu. And these new features were added in 2012. We support project templates and project provider. And there were significant changes in 2012 to allow VIPM to build add-ons and tools to be that support the project provider framework. And more information can be found on ni.com about what exactly it is. But it's basically add-ons that target your project environment. In the source file settings, you can define, this is where you define your password protection. You can have a random or custom password. You can also apply file renaming. You can provide a suffix or a prefix. So when VIPM builds the package, it'll do renaming for you. So you can do that if you want as well. And this, again, allows you to keep your source intact and during the build process, apply these changes. I'd like to show you the custom actions. So we have quite a few custom action capabilities here. During the build process, you can define actions that happen before the build and after the build. And during the install process, you can define things that happen before install, after install, and during the uninstall process. And here's some VIs that I've defined here. If I go into that, so this is one of the custom action VIs. This is a template that we provide that allows you to do custom actions. And some of the things that we allow you to use is the package name, the LabVIEW target version, the VIPM version, whether or not VIPM is in quiet mode. And quiet mode is basically if VIPM is being executed from the API. You can detect if mass compile is on, if refresh palettes is on. These are the features that are part of VIPM during the install process. So you can see these things. So you can use these actions during the install process. So that was just a sample of some of the things we expose for you during the install process. I'd like to talk about network repositories. Now, once you've built your package, how do you distribute it? One way is to email the package to someone, or you can use a USB stick and transfer it over, or you can put it on a folder location on the server and have people copy them over locally. One solution that VIPM offers is the ability to have network package repositories. And what this is basically a central location where it could be an internal or an external server where you can actually publish your packages. So once packages are published, a VIPM client, which basically is a computer that runs VIPM, can subscribe to a certain repository. And what that allows them to do is to get updates when new versions of the package are available. And it also allows a remote, always-on location where these versions and the history of all the versions can be available, so you can easily roll back. So you don't have to keep all that locally. You can have multiple repositories. VIPM supports an unlimited number of repositories. And a VIPM client can also subscribe to multiple repositories at the same time. So if you like to segregate your code between different groups, you can create a repository for each group. So the network repository could be an internal or external server. It can even be a public Dropbox folder, and we'll show you in the demo how to do that. It's basically a collection of files. So there is no server software that runs on your server, which is great because it's very lightweight. It doesn't require IT involvement. Any computer shared location can be your repository. So because it's just a collection of files, it can easily be backed up by your IT department, just like any other file. One thing that additional benefit to the repository is because you have the central control of packages, you can actually deprecate them. So if you want to outdate a certain package, you can deprecate it and force people not to use it or not see it in their list. And of course, you can totally remove it from the list as well. And also we have an RSS feed of updates. So you can have other tools that pull in XML files, read in the repository feed, and get notified when new packages are available. On the client side, like I said, it's a computer that any VIPM can be installed. They could be developer computers. They could be your subcontractors that you have in your company. You can give them a copy of VIPM to connect to your repository. They can even be, systems that with no user. It could be test stations that perhaps are running some LabVIEW code that you want to update as well. And since VIPM supports these custom actions, you can even have packages that just target various system locations instead of just the development environment. So I'm going to go through a quick demo of how to use a repository. So the repository management, so VIPM can do all these things as one product. So there are various areas of VIPM, and it's all in the same product, and it's a single piece of software. So there's not sort of a repository version or a package building version. It's all one version. So clicking on this button will allow you to set up your first repository or access other repositories. Since we don't have a repository created yet, it'll ask us to locate it. So what I've done here is I've already configured my Dropbox. And if you're not familiar with Dropbox, basically Dropbox is a remote server folder that syncs with your local hard drive. So I've created my Dropbox, and this is the public, and this only works with public folders, by the way. And I've created a subfolder called VIPM demo, and I'll select it and give it a name. And right now, you'll see that the repository is empty. So what I'll do is I'll add a few packages to the repository. Now, I have built a whole bunch of them over here, so I'll just grab a few. And so, are you sure? Say OK. And the name of the product is shown up here, and all the different versions are here. And this is where you actually manage your repository. And once they're in here and you close this window, the packages are published. Individually, you can select each version and you can unpublish, which is removing it, or you can deprecate it. So I'll just close this. Now we'll give it a few seconds for Dropbox to do its synchronization. And we'll see that it's all synchronized. And this is how it looks. It's basically a collection of files. And here is your RSS feed file. So just pointing to that will get you your RSS feed. So now I'm going to switch gears and go to the client side. So because VIPM can do both managing repositories and connecting to repositories, I'm going to sort of switch my hats, and now instead of becoming a repository manager, I'm going to be a client and connecting to a repository. So in order to do that, I have to actually connect to it. So in my VIPM options, I go to network. And here's a list of all the repository subscriptions I have. I can just add a repository. Now I have to add the public URL to the repository. I have it pasted here for convenience, and I'll show you how to get that in a second. And this is actually public, and anybody can subscribe to it. Now you guys can do that now if you have VIPM. I just copy that, paste it in here. And that's it. So I can do a check for updates. And right now what VIPM does is it goes out and looks at all the repositories that I've subscribed to and tells me if there's anything new out there. The VI package network and the LabVIEW tools network are built-in repositories that VIPM automatically connects to. Okay, so here's my repository name. I called VIPM public demo, and here's the latest version of this package or this product, this driver. If I right-click on it, I can see that I have multiple versions of it, and I can install any of these versions because they're all in the repository. If I double-click on it, it'll bring up the properties of that, and all the information I did during the package building process shows up here. And I can go ahead and install it. Okay, so it's confirming that that's what I want to do. And in VIPM, we always confirm everything. If it's just one package, it's simple, but sometimes you have 10 or 20 packages and you like to confirm that sometimes. And this is the license agreement. Of course, we can all agree that I'm great. But this is like a dummy license agreement that I added just for demo purposes. And this is what you have to agree to first. Now, if you're installing multiple packages, you'll see that they all populate in this list. Okay, so we can close that. Now, if we go back into LabVIEW and look at our palettes, we'll see that there's the category, the company category that I created. And this is the first package underneath that category. So here are my palette items that I designed. So one thing I'd like to talk about right now is a little bit about the way that VIPM handles dependencies or allows you to be modular with your reuse. Now, some people, because the tools were not available, created basically one monolithic reuse library. You know, they tell their developers, hey, go to this SVN repository or source code control, version, download everything into your LabVIEW folder, and you've got everything. So what happens if you know someone defines a bug in a specific VI? How does that get updated? Do you update the entire library? Do all projects get the whole library with all the changes? So it's tedious to do revision control and know what version of what is used by which project. It's hard to know. Every package has a version. You can roll back or go forward to any version. But we go one step further and we allow for packages to depend on other packages. Now, what does that mean? That means that a specific VI in one package calls a VI in another package. And in this case, for example, I have the instrument driver package, but as a company, I've created a specific database interface API. We have a database in our company that talks a certain way. So I interface in a specific way, and that's a proprietary thing to our company. So I create a special package for that. We've also developed some special fast math algorithms that also are proprietary and are specific to our company. But the instrument driver calls these two. And I want to be able to manage these two modules independently. Well, I can. I can with VIPM because during the package build process, the instrument driver declares a dependency with these two others. So what happens during install? When you go to install the driver, VIPM inherently knows these two dependencies exist and will actually put all three packages in your list. Even though you try to install the instrument driver, it'll actually include all three in the list of things you need to do to install this package. So VIPM handles that for you. You can also declare conflicts. I don't like, for example, database interface version 2.0. I want version 3.0. So you can define a specific version and you can say, well, I conflict with anything else outside these versions. So you can also define that as well. So you always want to stay at a specific version. And we mentioned about deprecation. Once you deprecate a package, it doesn't totally disappear from your repository. It's still there. The reason why deprecation maintains the package in the repository is because if you need to roll back to it, even though it's deprecated now, in an older version, it possibly was not. So you'd like to be able to still go back to it. And how deprecation shows up in the VIPM UI is it's very bold and it's in brackets says, this is deprecated. So it's very clear what's deprecated. Now I'd like to talk about a little bit about your project configuration. Now, a project is basically either a LabVIEW project or a specific system configuration of VIs. And you install, as we mentioned before, different packages to that system. Now, what happens here is this is all fine and great, but how do you define that my system uses these specific versions and these specific packages? How do you map that out? Well, in VIPM, we've come up with a system called a VI package configuration file. And that's something that wraps all of these packages into another file. But what this is just a definition of what the packages and the versions are. And I'll show you a little demo of that as well. So when you apply a configuration, you ensure that the correct VI versions are installed and that your system contains all the packages used by a project, packages used. You can do version control. So it maintains the specific version of the package. You can actually have the package inside the VIPC file, or you can have a reference to it. And the difference is basically, do you want to carry that package around with you, or do you want to point to it in the repository? So it makes the file smaller. So it literally becomes a reference to the other files, the other packages. I'll show you a little demo of that. So I'll open up this project here. So I've created this super lightweight project. And on the diagram, I'm calling a VI from my package. So I can, this new package I built, I can drop another function from it. I don't like seeing broken VIs. Okay, there you go. So I've created this project, and I'm calling VIs from my reuse library. But how do I know what reuse library I'm calling? How do I define this configuration? So in VIPM, we have yet another button here called Show the VI Package Configuration Editor. I'll open that up. And it looks similar to the other window, but basically this is a list of what packages my project uses. So we have a button here which allows you to scan the project. So if I scan it, and by the way, in 2012, we now support scanning of project files. It's just telling me that it needs to talk to 2012. That's fine. So it goes through and scans the project hierarchy and lists everything it needs. And it says, hey, you're calling this package directly. But by the way, this package has these many dependencies. So I'm going to add them for you as well. So you just continue. So now you have a definitive list of what's called by your project, and you have the exact version. Now, by default, this is configured to include the packages inside of it, and that's what this symbol indicates. But you can easily uncheck this, and it'll just keep a reference to it. And then I can save it. So now so you'll see that here, there's a VIPC file called demo VIPC, and that defines all the package configurations. The size is about 16 kilobytes. If it actually contained the package, that would be several megabytes because it would actually include the package itself. Now, what I like to do is just to keep things organized, I like dragging the VIPC file into the project so I know it's there. So if I uninstall this, actually I'll uninstall, let's say, a dependency of that. I'll just uninstall that one. I picked a package that has a lot of files. Okay, there we go. So if I open the project, you'll see that it's not exactly broken. So the main VI, you'll see that it's not exactly broken. Mainly because I'm not directly calling the sub VIs in this VI, but the package depends on it. So I don't know exactly. In worst case, you will actually be you'd be uninstalling the package that you're actually calling. But because you have a configuration, you can just apply that. So if I open the window, I'll just open the recent one to make it quicker. And I can say apply configuration. And it says, oh, you need to install this package because that's what you're missing. And I can go through that and install it. Another way I can do the same is just by right-clicking the VIPC. Okay, there you go. You can apply the configuration just by the right-click menu, or by highlighting it and clicking the apply right here. That's the default action. So one new feature that we introduced in VIPM 2012, there's a typo, new for 2011, I should say new for 2012, is that is the VIPM API. Now, I'm very excited about this because it basically allows you to do a lot of automation. Basically everything that I just went through in the demos, you can do with the VIPM API in an automated fashion. And all the APIs have a flag called silent mode, which basically executes the action in VIPM and eliminates all the dialogues. So all the dialogues we saw saying, are you sure, this and that, basically all those are suppressed. So you can do various automation. You can manage your VIPM package library. So every VIPM client, or every version that you've installed locally, you have a library which indicates, what packages you have, what versions, and so on. So you can actually manage that library. So you can add packages to your library, install things, refresh the list. You can do check for updates on your library. Package building, you can build a package, you can edit some of the package parameters. You can create VIPC files. So you can dynamically create, you can scan your project automatically. You can automatically create your VIPC file. Repo management, you can do publishing, unpublish. So you can do that as well. We have other utilities like minimize VIPM, maximize, exit VIPM, those type of things. And here at the top are the most common is install a package and uninstall a package. So one example of some of the things you can do with this API, if you build a lot of packages or you find that that's a tedious process, you can automate it. So building a package, installing it, you can test it, you can run certain test suites on it, and then you can publish it. Unattended system updates, you want a system to check for updates, install updates. Perhaps you want, because you can have multiple repositories, you can even dedicate a repository that's just for a system. So anything that's in the repository only belongs to that system. And then every time you put a package up there, the system, you can create some software that does check for updates and says, oh, I have new packages, I need to install them. If you have a big team and you want to reduce the burden on yourself for managing packages that get published to the repository, You can set up a server which allows people to put packages in a folder or send them by email. And then you can have a tool that just checks that and just publishes the packages. A lot of people set new systems up. When you're setting up a new system, you need to make sure that certain configurations are applied. The cool thing about the API is you can actually install a package on multiple LabVIEW versions at the same time, if that's what you want. You can do system inventory maintenance. You can say, well, are these packages installed? Are they the right versions? And you can do that type of thing as well. So one demo here that I have, I'm not going to run through the demo because it takes a bit of time, but I'm just going to show you the code. And just a sec here. So this is a simple implementation. And basically there's a button here where you run the code, you click check, and it does check for updates. This is just an example of what you could possibly do. You start up the VIPM, you do a check for updates, and if there's an update, it'll tell you. And here we also do more fine-grained check of updates. So you can actually, after you do a check for updates and your library has been updated, you can list the contents of your library. And if we take a look at this VI, you can see what package name you have, the version, the display name, what repository it came from, the company name, the license type. You can tell if a certain package is installed, deprecated, if it has a conflict, if it's been downloaded physically onto your computer. So you can basically get a very good feeling of, on your system, what state each package is in. This is a VI that I wrote. I can make it available, which basically does some additional checking, saying that to make sure that you do better checking on if you have new updates. Because VIPM has built-in check for updates on installed packages. It doesn't give you updates on stuff that you haven't installed because you don't care about it. But you can actually, comparing to what's in your library, and based on certain flags, you can tell that if there's a new version of something, then you can do manual manipulation of the data. So this is a tool that basically brings up a dialog. This is what new. Do you want to install it? Yes. And you go ahead and install it and then exit VIPM. This could just as well be some code that sits in your taskbar or your system tray. And you can add a timer in here that does this on a timed basis. You can actually do filtering and say, only packages that come from this repository I care about, or packages with these names I care about. So you can, do your own coding to do that. And hopefully we've provided enough capability to allow you to do that. We're very interested to get feedback on this. If there's something you need that we're not handling, then, let us know. Okay, and that's it. And all of this stuff that I showed you right now can be available, and you can try them right away. You can download your 30-day trial, and you can try it out. So all these features are available on the trial. There's no limitations for 30 days. The parts of it, so that we have, as some of you might know, we have the free version and the pro version. So there's just two versions of VIPM. The pro version gives you access to the repository management system and also gives you access to the VI package configurations. And the free version gives you access to installing packages, of course, and also gives you access to package building. So certain package building features are part of the pro version, and that's primarily password protection of VIs, tying into licensing and activation, which I didn't talk about, but basically licensing and activation. So VIPM supports a third-party licensing and activation toolkit from National Instruments. So we tie into that, and that's part of the Pro. And also custom actions for the build process are in Pro. The custom actions for install and uninstall are included with the free version. So that's primarily the dividing line. So I'm going to open up the floor to questions. And if there's any questions, you can type them into the question box. So someone asked about if do the clients that connect to the repository need to be Pro? Yes, the clients that connect to the repository need to be VIPM Pro. So there was a question about categories of packages, where you can define categories where certain level of packages are, level 1 would be use at your own risks, level 2 semi-tested, 3 rock solid. I would say that no. First of all, the short answer is no. We don't have specific categorization. You can segregate those type of packages by using different repositories, perhaps, and pulling them in from different locations if you want to isolate them that way. Another way is to build that into the naming convention of your packages, or the versioning system you use. So you can do something like that. That's definitely a feature that we're interested in. That's definitely something that we're interested in. We also have a VIPM ID Exchange website where you can find that on jki.net/VIPM. There's a link to that there. So we welcome any kind of feedback for additional changes or feature requests, and that seems to be a very, very, very good feature. A suggestion. So someone is asking about migrating your installation from machine to machine or something like that. That's what the VI package configuration files are for. It allows you to since you're managing the packages in the VI package configuration, that's portable, and you can take that to another system and apply the packages. As long as they're in that configuration. I'm thinking that's what you're asking. Can you build a package for a previous LabVIEW version? No, because that would require you to do downsaving, and that's not a built-in feature of VIPM. So, however, you could use that. That's a feature in LabVIEW. Not to say that we couldn't implement that feature by just sort of pointing to the linking to the LabVIEW feature, and because basically LabVIEW has save as previous version, but the package builder does not tie into that, so you'd have to do that as a manual step. Yes, someone asked, can you is there a trick to naming conventions in the palette? Yes, VIPM respects the underscore in package and VIs that are located in folders that begin with an underscore. So in your source, if you have VIs that are in a folder that have an underscore, those will not get installed in the palettes. So they won't show up in the palette, sorry. So we do support that. The one question was, do you need an HTTP server for a repository? No, you don't. We support, you can put it on your local hard drive. You can put it on your, we support UNC paths if that's what you're looking for. We support internal server name paths. So you don't have to have an HTTP server. I can go into VIPM here. So I can show you, sorry. So here are some examples of, we support FTP sites, HTTP, mapped drives, network shares. So we support those type of naming conventions when connecting to a repository. So there was a question for supporting LabVIEW on the Mac. We do actually support LabVIEW on the Mac currently. The version of VIPM is 2010 that supports the Mac. We are currently planning a release for 2012. Soon being within the next month or so, or two. No guarantees there. But if you have problems installing VIPM on the Mac, then you can contact our support. We have a document on the knowledge base that describes how to do that and how to work around a certain limitation in Lion right now. So there was a question about defining what VIPM Pro can do. So basically, VIPM Pro is needed to actually connect to repositories, just like I'm showing here on the screen. But you don't need VIPM Pro to install packages. They can be installed from anywhere. That is not restricted. You can do, you can also, in the free version, you can also apply a VI package configuration. You can't create one, but you can apply a VI package configuration. So you can say File, Apply Configuration, even in the free version. But you have to have the Pro to actually create the configuration. But yeah, installing and uninstalling, all that stuff's in free. So I wanted to also mention that one thing I didn't demo is anything related to the LabVIEW Tools Network. When you first install VIPM and load it up, it by default connects to the LabVIEW Tools Network. Some of you have asked in the past, can that be disabled? And yes, it can. And if you need to do that, you can contact me offline and I can show you that feature. But also, I didn't show you this part of VIPM, which is the actual LabVIEW Tools Network. And this is the view that is actually called from the LabVIEW Getting Started window. And this is dynamically populated in real time from the LabVIEW Tools Network. And any new packages or products that show up on there are shown in this list. And currently there's about 122 LabVIEW Tools Network, all certified working with LabVIEW products. So I thought I'd want to mention that as well. And most of them use packages for their distribution method. And you can tell that they use packages because they have the install button. So the ones that don't just have the download. Yes, is it possible to run a Windows installer to install a device driver? Yes, you can use a custom action. And as long as that driver is packaged together in the package, you can call that executable or whatever that is to during the install process to do what you need to do. I've done a lot of crazy things with custom actions, and you can do pretty much anything that LabVIEW can do. Is it possible to modify the install destination at install time? The simple answer, no, you cannot. So that is defined by the person who created the package. So the installed destinations are all defined up front by the package builder, and it kind of guarantees that things will happen as they should. We currently have no way that I know of to modify that during the install process. So someone asked the question, which is one that we're interested in as well and resolving, is how to update all VI links to installed packages. So way up front, I mentioned that you can extract code from your projects and then you can build them into a package and then install them. But then the question is, how do you go back to your project and relink to the new installed packages? And this is a challenge and a problem that we're working on. And we're working actually on a tool to be able to do that easier. Currently, there's no built-in feature in VIPM to help you do that, and it's a manual process as always. It's like, well, how do you relink to something new? The way you always do in LabVIEW. Very tediously. So right now we're actually working on a tool that will allow you to do that. And it's not ready for prime time yet, but there's something that we're working on which allows you to define your relinking. So that about wraps it up. We've run out of time, and Looked like were a lot of questions and a lot of interest in VIPM. I appreciate that. Until next time, goodbye, and thanks again for joining us.